Hello everybody, in this video I'll be explaining power of the points, not explaining, proving power of the points problems. So I won't really be doing any power of the point practices, it will only be proving it. So the first power of the point problem we're going to prove is the standard power of the point problem that you will see in most definitions of the power of the point. Um, the standard one says that AE times EC will equal BE times ED. In like if there's two lines intersecting in the middle of the circle. So basically, blah blah blah, how do we prove this? So you first draw a line from A to B and D to C, as I already done. Right off the bat, you can see that ABE and EDC are congruent. Why? They share a congruent side, not the ABE and EDC are similar, not congruent, but you can see that ABE and DEC share a congruent angle at E right here, and then you can see since there are two triangles in a circle made out of two intersecting lines, these two will also be congruent to each other. These two angles will also be congruent to each other. So when you draw the triangles out, this is not really a good triangle. Wait, it's gonna be more like, let's just say that this is what the triangles look like. This is obviously not what the triangles look like, but let's just say this is how the triangles look like. But let's just say that this is A, this is B, this is E, and this is D, this is C, and this is E. This is not what the triangles look like, as you can see, but we're just going to go with it. So it will be A, E, B, and D, E, C. So since we know that these are all similar triangles, we can see that D, E, let's label that E, and E, C, let's label that B. This is C, and this is D. So you'll know that A times D will equal B times C. Why? Because if these angles are similar, these angles are similar, and these angles are similar, then congruent, then it just like has a rule that A times D and B times C will be the same. So plugging the numbers, we'll find that AE times EC will be equal to BE times ED, which proves the first power of the point problem. So the next power of the point question we are going to be proving is the secant tangent theorem. So the secant tangent theorem states that AB squared will equal BC times BD. Why is this? It's again similar triangles. Let's say we draw a line from AD and CA. We can see now that triangle ABC shares a common angle B with ADB. And you can see that since these two, since there's like a line here, you can see that this angle will also be congruent to this angle, and this angle here would be congruent to this angle. So since we know that this small ABC is congruent to ADB, we can draw a triangle, a real triangle, not a bad triangle that I did last time. Like this, and then another one like this, and then we will label this A, B, C, and D, B, A. So if we say that CA is A and CB is B, and then, oh wait, no, if we say that AB is A and then CB is B, and then we say that AB on this triangle is C and DB is, or BD is D, we can see that B times C will equal A times C. Wait, no. We can see that B times D will equal A times C. So we know that A times C and A times C, A and C are both AB, which means A times C would equal AB squared, and B times D is BC times BD. And that proves the secant tangent theorem. So the third power of the point question, the third and final power of the point question that we are going to be proving is the secant theorem. The secant theorem states that CB times CA equals CD times CE. Why is this? If you guessed similar triangles, you are correct. If you draw a line from A to D and E to B like so, you can see that the triangle EBC and ADC all share a congruent, all share an angle C. And then you can also see that CAD and BEC are congruent. Why? Because this angle BAD and BED create a same length arc on a circle. So that means they are congruent. So since we know that these two triangles are similar, we can draw them out like so, right here, and right here, like this. And this will be A, C, D. This will be E, C, B. So, you know that this is like this is like this. So when we have this, we will know that AC, we can label AC as A, BC as C, DC as B, and EC as D. We'll know that AC equals BD. Yeah. So when we plug the numbers in, when we plug the sides in, we will see that A is AC or CA times C is BC or CB will equal B, which is DC or CD, times a D, which is EC or CE, like this. And that proves the secant power theorem. Thank you for watching. I hope you enjoyed this, and I'll see you next time.